Welcome. In this video, we'll be talking about three different types of linear equations and how you'd express the solution to each type. So the first type of equation is the one that's probably most familiar, and that's a conditional equation. So I've put an example of a conditional equation right here. And let's go ahead and solve it, and I'll show you what I mean by conditional. So if we solve this equation, minus 2 from both sides, and we get 3x equals 3. And then if I divide both sides by 3, I'm left with x equals 1. Well, what that means is that this equation is true if, and only if, x is equal to 1. So it's only true under certain conditions, and those conditions are if x happens to equal 1. It's not true if x is any other number, for example. So a conditional equation is true for some x values. Let's look at an identity and see how that differs. So if we use the distributive property, we'll have 2x plus 3x plus 12 on the left-hand side. On the right-hand side, we'll have 5x plus 10 plus 2. And if I put together like terms, I'll have 2x and 3x is 5x plus 12 equals 5x plus 12. So notice that the left side and the right side are exactly the same. What that means is if I stuck a number in on the left-hand side for x, say like I put 2 in for x, well, 5 times 2 plus 12, would that be equal to 5 times 2 plus 12? Well, clearly it would, because we're doing the exact same thing to the number on each side of the equation. And so if I put in any number for x, 3 or 10 or 12, regardless of what I put in, the left side and the right side are always going to be equal to each other. So my solution for this one would be all real numbers. Okay, and then let's look at the last example of an equation. And so, by the way, an identity is just an equation where the solution is all real numbers. Let's look at the last one. So if we distribute again, we'll have 3x minus 3 plus 1 equals 2x plus 1x plus 1. So that gives 3x minus 2 equals 3x plus 1. Okay, now let's think about what would happen if I stuck a number in for x. So suppose I use 2, for example. Well, what I'm doing on the left side is I'm multiplying 2 times 3, and then I'm subtracting 2, and that's what I'm doing on the left side. On the right side, I'm taking 3 times 2 again, but this time I'm adding 1. Well, clearly those won't be equal to each other because I'm multiplying both values of x on the left and the right side by 3, but on the left side I'm subtracting a different number than what I'm adding on the right side. So no matter what I put in for x, these two sides are never going to be equal to one another. Because on both sides, no matter what I put in, I'm multiplying by 3. But then to finish off the left side, I'm subtracting 2, which is going to give me one number. To finish off the right side, I would be adding 1, which is going to give me a very different number. So my solution to this type of equation, well, my solution is there's no solution. And that's really what a contradiction is. It just means there's no solution. So it's an equation with no solution. Okay. I want you guys to try number 1 and figure out whether it's a conditional, an identity, or a contradiction, and then circle the appropriate answer. Pause the video and then restart when ready. Okay, so let's take a look at this one. So if you use distributive property, 6 times x is 6x minus 12 plus 2. On the other side, 2 times 3x is 6x minus 10. So if we simplify each side, you should have 6x minus 10 equals 6x minus 10. Those are exactly the same thing on each side. So what that means is we have an identity. All real numbers are going to be the solution. Okay, let's try number 2. Pause the video and then restart when ready. So for number 2, if we use the distributive property, we get negative 8x minus 8 equals 2 minus 8x minus 9. And if I simplify each side, what we end up with is, well, 2 and negative 9 can be combined to make negative 7. So we're left with negative 8x minus 7. Well, notice now on the left side, any number we're putting in for x is being multiplied by negative 8. And then we're subtracting 8 from that result. On the right side, again, whatever number I'm putting in for x is being multiplied by negative 8, just like it is on the left side. But instead of subtracting 8, we're subtracting 7. So that's never going to work. So this would be an example of a contradiction, which means we have no solution.